Okay, today we have lesson 9.2, simplifying exponents. So you've seen this before for sure last year in advanced algebra. So here's a bunch of rules. I don't really care if you remember what they're called, but you need to be able to use them. So power of a product property says that x to the a to the b equals x to the a times b. So you multiply the exponents. So for example, x cubed squared is the same as x to the 3 times 2, which is x to the 6th. When you have the same base being multiplied, you add the exponents. So x to the a plus b. So for the power of a power, you have just a power hanging out here on the outside by itself and you multiply. Here, same base, you add. So for example, x to the 4th times x is the same as x to the 4 plus 1, which is x to the 5th. For the quotient of powers property, essentially when you divide and you have the same base, you subtract the exponents, so you get x to the a minus b. For example, if you have x cubed divided by x, you would get x to the 3 minus 1, which is x squared. Power of a product, basically it distributes. So x will be to the b and so will y. So x to the b, y to the b. For example, xy to the 5th will give you x to the 5th, y to the 5th. Again, distributes. Power of a quotient, this also distributes. So x over y to the power of b gives you x to the b over y to the b. For example, x over y cubed is x cubed over y cubed. If x is any non-zero real number, x to the 0 is 1. So anything to the 0 power is 1. Negative exponent theorem, it's just kind of a rule. You can call it a theorem if you want. X to the negative n equals 1 over x to the n. For example, x to the negative 2nd power is 1 over x squared. 2 to the negative 3rd power equals 1 over 2 cubed, or 1 over 8. So simplified answers should include only positive exponents. You should also simplify as far as you can, meaning if you have x's, you should only have one x in a single power. If you have numbers, you can't leave it as 1 over 2 cubed. You'd have to go to 1 over 8, or as far as you can. So this lesson is really just showing you a bunch of examples. The big thing I want you to keep in mind is there's, well, not quite infinite, but there's a ton of different ways you can solve these. As long as you use the rules properly, it doesn't matter what order you go in, you will get the same answer. So I have preferences that I tend to choose. Some people like to do some things first, some people like to do other things first. Some things are quicker, some things are longer. But again, if you use all the rules properly, you should get the right answer no matter what order you choose. So for this one, for the first one, 3x to the negative 2nd, I'm going to start by just distributing that negative 2. So we'll get 3 to the negative 2nd, x to the negative 2nd. And now from here, whenever you have negative exponents, you're going to need a fraction. So I'm going to make a fraction bar, 3 to the negative 2nd, to make that a positive power, to put it on the bottom. X to the negative 2nd, make it positive, make negative 2nd, make it positive, put it on the bottom. There's nothing on the top, and we have to have something there, or it doesn't really count as a fraction, so I'm going to make it a 1. Simplify one more time. 3 squared is 9, so we have 1 over 9x squared. For this next one, again, the exact order doesn't really matter. We have a fraction bar here, so I'm going to draw another one. I'm going to simplify the numbers first and say 5 over 25, well, that simplifies to 1/5. And now I have a y to the negative 5th. I want that power to be positive, that exponent, so I'm going to put that on the bottom. So make y to the 5th on the bottom. X to the negative third is on the bottom. I want a positive power, so I'll put it to the top. So basically, to make a power positive, you flip it to the other side of the fraction. You don't need a 1. You can keep it if you want. I'm going to rewrite this as x cubed over 5y to the 5th. For the next one, the first thing I'm going to do, you could leave it to the end if you wanted, but y to the 0 is just 1, so I'm just going to get rid of it because it's just multiplying the whole thing by 1. Now from here, I'm going to simplify across. So 4 times negative 2 is negative 8. X to the negative 7th times x to the 5th is x to the negative 7 plus 5. So we have negative 8x to the negative 2nd. We can't end with negative exponents, so I'm going to make a fraction. The negative 8 stays on the top because that exponent does not apply to it. So we have negative 8 over x squared. For the next one, I'm going to distribute the negative 3 first. You could go in a different order. So I'm going to keep the 4x, and then we have 2 to the negative third, and we have x to the negative third. So what I'm going to do is make a fraction bar, because whenever I have negative exponents, I'm going to need a fraction at some point. The 4 and the x have positive exponents, or really no exponent, but they go on the top. 2 to the negative third, put it on the bottom, make it a positive exponent. X to the negative third, put it on the bottom, make it a positive exponent. So we end up with 4x over 2 cubed is 8, x cubed. Not quite done. Keep our fraction. 4 over 8 simplifies to 1/2. Now we can, there's a couple ways to do this. I'm going to show you the way I tend to do it. This is like an x to the first power. So if we simplify this, it's a fraction. We'll subtract the exponents. 1 minus 3 is x to the negative 2nd. So I'm going to put it to the bottom and make it positive. So we get 1 over 2x squared. Next one. We have a fraction. I'm going to keep a fraction. 10 over 8 simplifies to 5 over 4. X squared over x to the negative third. Well, we're going to have an x, and we can do 2 minus negative 3, which is 5. So we have a positive 5, so x to the 5th goes on top. For the y's, negative 2 minus a negative 1 is a negative 1. So we're going to have y to the first on the bottom. So I usually don't keep the 1 in the power. You can if you want. So I would rewrite this as 5x to the 5th over 4y. Next one. Again, your exact process is up to you. I'm going to make a fraction bar. I'm going to distribute this. So we have 5 to the negative 2nd, x to the negative 2nd, and then we'll bring this z to the negative 2nd over. We have x to the 4th, y to the 0 goes to 1, so I'm just going to eliminate it. Z to the negative 3rd. Okay, let's go again. Or keep going, I guess, more accurately. So 5 to the negative 2nd, put it on the bottom. X to the negative 2nd over x to the 4th. Well, negative 2 minus 4 is negative 6, so that's an x to the 6th on the bottom. The z's, negative 2 minus a negative 3 is like negative 2 plus 3, which is the first, so we end up with a z to the first power on top. So we end up with z over 25x to the 6th. Next one. It looks like we can't simplify across at all, so we'll go top to bottom, meaning, you know, x is on top, x is on the bottom, etc. Keep our fraction bar. The 2 and the 3 stay, so you can't simplify it. X to the 4th over x squared. 4 minus 2 is 2, so we have a positive squared, positive, or x to the positive 2nd power, x squared. The y's, negative 4 minus negative 3 is negative 1. So we have y to the negative first power. I'm going to put it on the bottom and make it y to the positive first power. z's. Negative 3 minus 4, negative 7. So I have a z to the 7th power on the bottom. You could keep it this way. I'm going to get rid of the first power for the y and make it 2x squared over 3y z to the 7th. All right, this one's a lot. You kind of just have to start somewhere. Exactly where you start doesn't matter as long as you do everything correctly in there. I'm going to distribute first. So I end up with 2 to the, and by distribute first I mean look for parentheses and distribute. Fractions there, so we have 2 to the negative 4th, p to the negative 4th, m to the negative 1 times negative 4, which is 4, and then q to the 0 times negative 4, which is just q to the 0. I'm going to fill in the rest of it. I'll just keep this. 2m to the negative 1st p cubed. Denominator is still 2pq squared. All right, there's more stuff we can do here. I'm going to switch colors in case that's helpful. If it's not, I'm sorry, but sometimes I enjoy changing colors just for fun anyway. Okay, so I see a few things going on. Let's see. First, I want to put this 2 to the negative 4th on the bottom. And the q to the 0 is a 1. I'm going to get rid of it. So now on the top, I have p to the negative 4th, m to the 4th, times 2 m to the negative 1st, p cubed, over 2 to the 4th, because I stuck that down in the bottom and made it a positive power, times 2 pq squared. And keep in mind also you can skip more steps, you can do more at once, just try not to make mistakes, so sometimes slowing down helps with that. Simplify a little bit more. Seeing this, 2 over 2 is 1, so those can go away. And keep this. I'm going to multiply across. So p to the negative 4th times p cubed, negative 4 plus 3, because we're multiplying, is p to the negative 1st. M to the 4th times m to the negative 1st. 4 plus negative 1 is 3. So we have m cubed. 2 to the 4th is 16. And then we have p, and then we have q squared. Getting really close. So to be finished, you can't have multiple spots with the same variable. Let's make this. So the m cubed, there's only one of them. It's going to stay. The 16, that's going to stay. The q squared, that's going to stay. And now our p's. P to the negative 1st over p to the 1st. Negative 1 minus 1 is negative 2. So we have p to the negative 2nd. Put it on the bottom and make it a positive exponent.